Hello, everyone. Thank you for joining our webinar. Today, we have partnered with Pix4D to overview our flight to finish workflow using GeoCue's TrueView 3D imaging sensors and processing collected data through Pix4D Mapper and Pix4D survey workflows. Before we get started, I would like to go ahead and do an audio check. Please notice the raise your hand button has been circled in red on the slide. If you can hear me, please click this button now. We still have some people joining us, so I'll give everybody a few minutes. Looking good, seeing lots of hands. Great. Looks like everyone can hear me. My name is Crystal Bailey, and I will be moderating today's session. Joining me today is GeoCue's President and CTO, Louis Graham, and our VP of Special Projects, Martin Flood, who will be assisting with answering your questions during the webinar. We are also excited to welcome the Pix4D team. Joining us today is Josh Haga and Nathan Moore. Josh is a Pix4D technical sales engineer based in Denver. He is an emerging geospatial professional with experience in photogrammetry, LIDAR, and autonomous mapping solutions. Josh actively supports the implementation of SUAS-based solutions into expanding enterprise offerings. Welcome, Josh. And Nathan is the product manager for Pix4D Survey, a new tool to help users more easily move from reality capture data, photogrammetry, and LIDAR to CAD and GIS. Before Pix4D, he worked at Autodesk, helping enterprise customers optimize their reality capture to design workflow. He started off in the industry doing high resolution, small format aerial digital photogrammetry and GIS, and he has a master's in GIS. Welcome, Nathan. Thank you both for joining us today. We're happy to have you. Before we begin, I would like, of course, before we begin, I would like to go over a few things. Group audio has been disabled for this session. If you would like to ask a question, please use the question box on your GoToWebinar panel. This session will be roughly 60 minutes with a Q&A session at the end. If we do not get to your question during this webinar, we will follow up with you by email. This webinar is being recorded and will be distributed to everyone registered. So at this time, I will be launching one of two opening poll questions. And we will start with, please indicate your use of drone mapping / inspection technology. Check all that apply. And we will be sharing these results with everybody once the voting is done. Give it a few more seconds. All right, so I'll go ahead and close that poll and then share the results with everybody. All right, so it looks like we got 69% that perform photogrammetric mapping using drones. Awesome. Okay, I'm going to go ahead and launch the next question. So I'll hide those. What's your biggest workflow challenge? And again, you can check all that apply. And we'll leave this open for a few more seconds. All right, so I'll go ahead and close that and share those results. And it looks like we've got close numbers for digitizing, cleaning data, and extracting information from point clouds, and also accurate data capture. All right, all good information. So I'm going to go ahead and hide that. Thank you all for voting. Joining me now is GeoCue's president and CTO, Mr. Lewis Graham, and I will hand over the presentation to him now.
Great, thank you, Crystal. Can you hear me and see my screen okay?
I sure can.
All right, well, thanks a lot, everybody, for taking an hour out of your day to join us for this webinar. Quick overview of what we do on the GeoCue side. And just to give you a little bit of context, we build LIDAR sensors with fused cameras, and we do the post-processing of that data. And we have a natural workflow into other products for data extraction. So that's really where we're going with this, is the front end from GeoCue, the back end from Pix4D. So we've been in business since 2003. We're located in Huntsville, Alabama, USA. We have an office in Toronto, Canada, and we've just opened an office in Brisbane, Australia. We're still privately owned. And our focus has been LIDAR and imaging technology since we started the company. So interestingly, we entered drone mapping in around 2013, and since that time, drone mapping has grown to be 47% of our business if you look at it from a revenue point of view. And we're able to do that without losing business in our other sectors. So it's really been a growth area for us. And I think for most of you on this webinar, it's been a big growth area for you as well. So it's a big opportunity area, and it's good that you're here taking advantage of that. We've done countless flights, over 3,500 and counting. We fly multiple times every day to calibrate sensors. We do some R&D for different collection techniques. For example, we're involved with the Department of Agriculture right now on a project to look at how we collect data for modeling earthen dams. So we do quite a bit of sort of eat your own cooking within the company. A few of the comments from our customers who really think that drone mapping, particularly drone mapping with colorized LIDAR, has really changed their business. It's really allowed them to offer some innovative products to their customers and put them out in the front of the drone mapping, say, emerging industry. When we started our TrueView product line about 2 years ago, our focus has been very much on an integrated ecosystem. I know that's an overused word, but the idea is that we have coupled technology that works well together, that ranges from web-hosted technology that we've built in Amazon Web Services to desktop processing, to the drone flights and sensors themselves, to direct visualization of data in our web services, generation of products directly within our own software that's included with our sensors, or the ability to push products at different levels to third-party software providers such as Pix4D. The sensors that we offer in the drone mapping arena at the high end of the family are what I call 3D imaging sensors. So these are sensors that include LIDAR for the 3D element, and then include cameras for the spectral side of the equation. And they can, there could be different types of cameras and different types of LIDAR scanners. And we do fusion at post-processing time directly in 3D from the individual images, as opposed to some post-processing where you might be doing it from an orthophoto. In LIDARs only, we do not offer LIDAR only, and kind of discourage you from going in that direction. If you're going to go get a LIDAR system, get integrated cameras that match the LIDAR so that you can do colorized point clouds. We've been in the photogrammetry business forever. We have a camera-only solution that'll be released hopefully this month, called the TrueView 250, which is a dual camera system for the DJI series M200, M300s. And then we also support photogrammetry systems as what I call guest sensors within our workflows. We'll also be supporting the new L1 LIDAR sensor that's coming out from DJI in Q1 of 2021. So I think everybody knows in photogrammetry you get great data, but it does have limitations, particularly in vegetated areas. So if we look at this site that we collected and processed using cameras only, back up a minute, then you notice that I have a nice canopy, but I have no ground penetration. When I bring LIDAR into the equation, now I've got ground penetration as well as a more defined canopy. So LIDAR really adds both the ability to provide multiple Z points per XYs, the ability to penetrate vegetation to the ground, and then the ability to get a little bit better definition. Now, of course, in LIDAR alone, you get a really nice detailed rendering of a scene. So here we have an example of rendering by elevation only, and I've modulated this by the intensity of the IR return from the LIDAR. And this is really nice. It's very valuable information. I can clearly go get points underneath vegetation that I would not be able to do in photogrammetry. But if I add RGB to this, what a difference it makes. So now, not only do I have the nice clean definition of LIDAR, but I've also got a lot of contextual information. Before, I couldn't really tell what was going on in these areas. I really couldn't tell what was going on in this drainage area, et cetera. And the RGB really brings clarity to that. So in the sensor arena, we offer what I call a utility grade sensor that's useful for all sorts of operations. It's your day-to-day go-to drone LIDAR sensor. We use a Quantergy M8 Ultra scanner that's a multi-return 430,000 point per second scanner, and then dual mapping cameras. And these are photogrammetric cameras because they have a mechanical shutter. They have electronic mid-exposure pulse that lets us synchronize it to the position and orientation system. And they are fixed focus lens, so they'll hold calibration. And then for positioning, we use a Planix positioning technology. We've had a relationship with the Planix for a long time, and they really understand what they're doing in 6 degree of freedom positioning. So that's our GPS IMU system. In June of this year, we introduced the TrueView 615 and 620 3D imaging sensors, and these are quite similar to the 410, except they upgrade significantly from the Quantergy laser scanner to a Regal Minivux 2 laser scanner. So this significantly reduces the amount of noise that you have in LIDAR data, and it also has better ground penetration because it's got a tighter beam, less beam divergence, and a better data collector for the return laser pulses. The difference between the 615 and 620 is the 620 adds an external IMU. This is important for, say, way off the hip shots where you have pretty severe horizontal angles that you need to capture in data, where precision of heading makes a big difference. 3D colorization, I just think these images are remarkable. So this is a 3D colorized point cloud, and the quality now that the density of LIDAR data is getting higher and our calibration processes are better, the clarity is absolutely remarkable. So this is what you ought to be processing, not just plain old LIDAR data. There's a set of specs for the TrueView 410, the TrueView 615, 620. The webinar is being recorded, so if you want to go back and look at these specifications, they'll be available. And also on our website, we have frequently asked questions for both of these sensors that you can download. We include all post-processing software with all of our sensors. There's two pieces to that in general. One is our own, what we call TrueView Evo, which is derived on our LP360 LIDAR processing software that we've had out in the industry for years, and we've added all the capability that is sensor unique, including the range processing of the LIDAR data, the colorization, and so forth. So within this one package, you can go all the way from ingest of the raw LIDAR data to colorized point cloud, automatically extracted ground, contours, line work, and so forth. And quite a few tools are included within the Evo software. So let's jump right in and look at the software itself. And what I'm going to do is I'm going to process to a colorized point cloud, and then we'll hand it over to Pix4D. So we call the input data a cycle, and we have quite a few options on importing cycles that I'll talk about in just a second. So I'm going to browse to a cycle. And this is data that comes off of our sensor. It's written directly to a USB memory stick. and we just ingest it directly into the PC. I just give my project a name. That doesn't already exist. Select the coordinate system I want to work in. Now, I've been in here before, so I'll just select, by the way, this is data collected by our customer 8th axis geospatial in a construction site in Hawaii. But if I had not already visited, we have a full complement of coordinate systems built into the software, so no problems there. The observation file comes from the base station if I'm doing local base processing. And an interesting feature that we have is something we call the survey nail that allows you to say, where was my base station set up? And we'll talk about that in a second as well. And so I'm at this point now where it says, okay, do you want to go ahead and bring this cycle, all of this information from the laser scanner, which is the imagery, the LIDAR data, and so forth, that's being transferred in and forming this project. So while that's importing, we'll talk briefly about the options that we have. So we've built archiving directly into our system because we've discovered that customers want a way to easily keep all of the data that they collected in the field in an easy and safe place to retrieve. And we allow you to archive what we call a cycle either locally or to Amazon Web Services. So you have those two choices. So you can bring it in and say, I only want to import it and process data, all the way to I want to include archiving in this workflow as well. And then I was talking about the nail library. And what this does is that it lets you keep a library of where you have placed base stations. And that's a very handy thing because when you want to revisit it and so forth. And we've built in interfaces for things such as loading directly from a National Geodetic Survey Opus file and just adding that to the library. So this makes it very easy to maintain base station locations as you move from project to project. So as we look back at our import dialog, it's just now finishing up importing this cycle of information. And when it's complete, we get a nice display that shows all of the data that was imported, ranging from log files to photos, superimposed over a Google backdrop map. So this is quite nice. It gives us all the information we need for data collection. Let's take a quick look at photos. So I'll just bring up this dialog that's built in. I can drive around and select a photo either from the graphic or interactively from the list. And you can see that we nicely show the photos from what we call the port and starboard camera. Brought right in. And we'll soon have an explorer that'll let you just pick a point in a point cloud and show where those images are located. So the next thing we have to do is post-process the positioning information, and we use a Planix POSPAC to do that. Some of you folks that are processing LIDAR data know that this part of the flow can be a little bit intimidating. So we built a wrapper around POSPAC so you don't really have to exit our application to go individually run it. You can run it directly from within our app. We bring up a dialog that interfaces directly to both POSPAC and also to our cloud service. Our 410 sensor, the Quantergy-based sensor, is available both as a subscription or an owned system. You can just outright buy it, or you can just purchase it as a subscription type system. And if you go with a subscription system, we have a scheme where we charge you a certain number of points to process each flight, and that's managed within our POSPAC application as well. So we go through the POSPAC. It picks up information that has already been loaded as part of the import wizard that we looked at just a minute ago. So you don't have to replicate this information. You just go through it. And when you're ready, just submit it. If you're a subscription-based system, it will run POSPAC in the cloud. If you own the system, if you purchase the system, then you'll have a copy of POSPAC desktop, and we coordinate through our TrueView Evo application with POSPAC. So again, you don't have to go into POSPAC and run that application separately. Now, it takes about a minute and a half for this project. I'm just going to skip that bit of it. When you're done, you have direct access to the POSPAC accuracy report. So those of you who really want to go through this sort of information, that's available. And let me drag that over here. So anyone that's processed POSPAC before knows that there's no end of information available in this report. And it is a good idea to check a couple of things within it to ensure that you have had a successful triangulation of the data. Once you've processed POSPAC, now what that does is it brings in all the raw data from the sensor and it gives you a trajectory, what we call a trajectory, which is a 200 observation per second file of XYZ pitch, yaw, roll, and time. And what we want to do is extract the bits out of that we want to use in generating the point cloud itself. So we typically don't want to do it for the entire flight. I'll turn off a bit of this, and I think I'll turn off this Google backdrop for a moment too. And so we have a tool that lets us take this complete flight and chop it down to what we really want. We have an automatic and interactive tool. So settings are things like what's the minimum length of a flight line, etc. And I can automatically compute the lines that I want. Let me turn off these trajectory points. And so here's it's saying here's the lines that I want to go process. Well, I don't really want all of these, so I can just simply delete the ones that I don't want. Let me grab my delete tool. I don't think I want those guys, and maybe I don't want these, a couple here, and maybe I don't want this one. And I think I'll keep the rest. And so it's that easy. And if I want to, if you're really particular, we have tools that will let you go work on this all the way down at the vertex level. So these are the flight lines that I want to process. And so we have an application that now will take the data that POSPAC created, that full trajectory, and extract the pieces that I need for processing these flight lines. Now, since I didn't run POSPAC, I'm going to go browse for the pause file, the trajectory file. Normally, it would have already been filled in. And we'll talk about this dialog in detail in just a second. So what I'm going to do is create trajectories from the pause data and assign it to the trajectories that I've created here in this project. And then the next step is to actually go and geocode the LIDAR data. So what this is going to do is bring in all the LIDAR data, take the trajectories, the range data from the LIDAR, and create a 3D point cloud. So we're actually going to go ahead and let this run. I do have some ability to control this a little bit. I can clip to maximum flight line I want, maximum range, things of that nature. We'll let this guy run. And as that's geocoding, we get status in the lower part of the window. And let's talk about a couple of things that are going on here. So one of them we'll talk about is running POSPAC itself. So if I'm in a subscription or an owned system, I can use a number of geopositioning techniques. You can see this LIDAR data being processed in the background. I can use single base. That's the most common. I just set up a base station on site. I can use a Planix Smart Base. This is a VRS or a virtual reference system, or I can use Trimble PPRTX, and this is a point positioning system that is quite useful. So PPRTX will work globally. I don't need a local base station, but I do sacrifice just a little bit of accuracy when I run in that mode. If you run in SmartBase or PPRTX, typically you would have a subscription service with Trimble, but we allow you to buy it just in time. So you don't have to buy a complete annual subscription. You can just pay a few TrueView points and use it in an ad hoc fashion. What we found PPRTX to be really useful is rescuing a project when something went wrong with the base strategy, like my base station battery went dead or something of that nature. And then this automatically computes uh, all the parameters that are necessary. The second part of this that we want to talk about is when we created the trajectories to process this product that are right now being used to geocode the LIDAR data. We manage calibration in our web-hosted application. You don't pay extra for this. It's just part of the base capabilities you get from GeoCue. And so when you process your sensor, we automatically go to our web service called Reckon. We find the correct calibration file for your sensor, download it, and apply it to your data. If you already have the correct calibration file on the sensor, then nothing's replaced. Otherwise, we do replace it. And you have ways of going and manually changing that if you want to. One other really handy feature we have is the ability to say, what photos would you like to retain for export into an application like Pix4D? And what I've said is I don't want all the photos. I just want the ones that are coincident with the flight lines that I called earlier in this process. So my data has processed. I now have my typical 3D LiDAR point cloud. I can look at this in the 3D view. There's the flight lines above the data. And here we have this quite nice, beautifully defined, crisp LiDAR data. And I can look at it by flight line, by return, by elevation, by classification, had I done any classification, etc. But I can't look at it by RGB yet. I have one more step in my toolbar workflow, which is to colorize the point cloud. And that's as simple as just saying colorize the point cloud. I just press a button and say go. Now this takes about 6 minutes, so I'm not actually going to do that. I've pre-colorized. I'm just going to go load that LAS data into my project that I had already colorized previously. And I'll just browse to that here. Load it up. So this is from this project. I just ran it earlier before this demo to get the RGB values. I'll switch over to that layer and we'll just switch our view now. This will enable viewing by RGB. We'll switch it into this mode. And look at how lovely that is. So it just makes a really lovely data set. So much more value when you're able to see the colorization in addition to precision 3D. So it's quite simple. It takes me longer to talk about it than it would take you to process data all the way to colorize point cloud. At this point, you can do a lot of processing directly within the Evo application, denoising, classification, line work, etc. Or you can just export the data, which is in standard LAS format, as well as the images to third-party apps. So we've included a couple of tools to make that easy. One of those is to update the EXIF tags of imagery with the precise 6 degree of freedom solution we have, pitch, yaw, roll, X, Y, and Z, and then build an export package for delivery to third-party apps, such as Pix4D. So at this point, we'll transfer it over to Nate and Josh.
All right, thank you, Lewis. I'll go ahead and steal the screen share here. So can you see the right presentation now, Crystal?
Yep, I can see it.
All right, now we're good. All right, so thanks, Lewis. I mean, you kind of said it there. That was some really nice looking data. I mean, I haven't personally used the TrueView sensor, but I learned a couple of cool things there, which was nice. And then for listeners, in case you weren't listening a little bit earlier, my name is Josh Haga, and I'm a technical sales engineer based out of our Denver office. So just located out here in Denver. And then here to talk with me about Pix4D is Nate Moore, and Nate's our fantastic Pix4D survey product manager. He's going to talk more about digitizing your data products and really doing a deep dive into some of these outputs that we get out of Pix4D. And then so now that we've captured data from TrueView and you've done all that calibration, and Lewis has really gone and showed us all that cool stuff you can do with their software, now we're going to show you what you can do with that TrueView RGB data once you take it out over into our Pix4D mapper software. So we'll go ahead and do that. But real quick, before we dive into the data, just giving you guys a really quick rundown on Pix4D as a company. So this is just a nice little map view we like to show. So we're very much a growing company with a wide reach with seven global offices now. So 7 global offices, and 200 employees. So our employee count's getting up there. I'm based in Denver, which is where our US headquarters is. And then we have our headquarters as a company over in Lausanne, Switzerland. So really getting big. And then you can see up there on the screen, we have over 50,000 active users, which is a lot of people, and we're mapping some pretty large areas. So at Pix4D, sort of our bread and butter is photogrammetry. And we make a leading photogrammetric software called Pix4D Mapper, in case you haven't heard of it. And this brings up a really good question, a really basic question. So what is photogrammetry? And just breaking it down in a really, really simple sense, photogrammetry is simply the science of measuring from images. And by using a lot of images and multiple perspectives of a given object or a scene, like in this project that we're going to talk about here in a bit, a construction site in Hawaii, you can digitize reality using our super advanced algorithms. So using these multiple perspectives, many images, you can go through and use this science of photogrammetry using our software. And here you can see just an explanation of photogrammetry illustrated in this little diagram. So we're taking all of these individual images and applying Pix4D Mapper's advanced algorithms, all of these images that you can sort of see on the left, and then we're getting high quality 2D maps, 3D models, and a lot of awesome data products out of the software. Here's a quick rundown on all of our products. And if you go to our website, you'll see that we have a lot of different solutions, a lot of different options. And I mean, really, it's a vast array of different products, from environmental research to surveying, telecom inspection, terrestrial modeling. I mean, we have tons of different solutions, and it's going to apply to a lot of different needs. So if anybody who's watching this has questions, do I use that product? Do I use this product? Just go ahead and reach out to us, and we'd be more than happy to help you find which product would be right for you. But today, I mean, we have all those products, but today Nate and I are going to focus on 2 main products, and these are Pix4D Mapper and Pix4D Survey. So Pix4D Mapper is our top industry leading software, and this software is going to process your drone acquired photos. And then once you have your data outputs from Pix4D Mapper, you're going to take those outputs, import them into Pix4D Survey, which is our really new software, which is great for vectorizing data sets, digitizing data sets, and just getting a little more out of your data before you import it over to third-party softwares like AutoCAD. So Mapper for processing, it's the software that's been around for a long time, and then Survey is our really new software, which is great for digitization. So let's actually talk about the project that everybody joined to hear a little bit more about. So we're switching gears. So this is a little project overview of the data set we're looking at today. So it's just an urban data set that was captured over a construction project in Hawaii. So you can see a crane there, sort of like Lewis showed earlier. You can see this main complex building with a lot of intricate geometry, some vegetation. And This is just a video animation taken directly from our Pix4D mapper software, so you can just get a high-level overview of what's going on in the software. This is really good for marketing and just detailing the project that you captured out in the field. It's really nice. So let's actually dive into the project. So to set up your project in Pix4D Mapper, we'll go ahead and launch the software here, let it load, and we'll start a new project. And as you create a new project in almost any software, you need to go ahead and name it. We'll give it a name, TrueView project. And then something you'll do in the software is you'll create a folder to store all of your Pix4D Mapper outputs. And we'll go ahead and do that. And because this is a new project, we'll go ahead and denote that it's a new project. And then in the next step of the process, we need to go ahead and add our images from the TrueView. And the TrueView is a super cool camera. I mean, Lewis talked about it earlier. You have this port and this starboard camera system on this system. So you'll have two folders, two different set of images that you'll need to import into the actual software to start off processing. We'll go ahead and do that. So for this project, you have 982 images. Then once we proceed, the software will go ahead and it'll extrapolate all that EXIF information and read that metadata. We'll go ahead and we'll denote the image coordinate system. When you use TrueView data inside Pix4D Mapper, for the most part, those images will be geotagged in NAD83 2011. So we'll go ahead and denote that. And then for our vertical coordinate system, we'll go ahead and slap it to ellipsoidal height. Go ahead and hit OK. And the next cool thing that you can do, I mean, this is a super accurate system, the TrueView system. I mean, this advanced IMU, geolocation, everything coming from it is super accurate. So with that, from their software, we're getting an extremely accurate OPK file, which is essentially the geolocation of the images. So it's giving us really accurate omega phi kappa orientation parameters for the camera, which are now imported into the software. So now the software will use that high accuracy information when it goes ahead and it processes the data. The next thing we'll do is edit the camera parameters. So another great thing that you're going to get out of the GeoCue software is some camera model distortions. And I'm not going to do it per se in this video, but with this file, you can actually go into the Pix4D camera model database and change the focal length, the principal point, and another cool thing you can actually go through and adjust is the radial distortion and the tangential distortion. And those are all great values to insert if you want to get more accuracy out of your data products. So we'll go ahead and hit OK. We'll move ahead. And then we'll set our output coordinate system. For this one, we are going to set the output coordinate system as the same coordinate system as we know our LIDAR data set is going to be in. And this is going to help us later when we take our point cloud, the photogrammetric point cloud out of Pix4D Mapper and line it up with the LIDAR point cloud in Pix4D Survey. And Nate will talk about that here in a bit. So the output coordinate system is fairly important, just getting that right so everything's going to line up later. And then last, before you kick off processing, we have a few different processing option templates, sort of pre-cooked models for you to go through and select. We'll go ahead and select the 3D models processing template. And then sort of similar to the GeoCue software, you can go over and get a high-level overview of where your images were. So right now we have the satellite map, and over the satellite map we have these individual red dots. Each of those dots are the images. You can go ahead and click on one if you want to get an idea of that actual individually acquired drone photo. So you can get a high-level overview of what's going on in the site, what do the images look like, and just sort of pan around there. So everything's good for processing at this point. The last thing we'll do is draw a processing area, and this is a really good thing to do to speed up processing. So right here, we're just drawing it in the map view, and a processing area is essentially just a boundary that says the software is only going to process data of everything inside of this region. So the software isn't using any additional resources to process points outside, so processing will be faster and you'll save more resources. So we'll go ahead here. So once processing is completed, now we have some really cool data products to actually navigate around in the software. So now we've gone from 2D images to full 3D data products. You can see your images in 3D up above, those green spheres, and then you can sort of see this individual point cloud in the ray cloud viewer here in Pix4D, and you can rotate around this, see that the vegetation turned out nicely, the crane turned out nicely, and now that we're in 3D, you can see those images that drop down there, sort of seeing an additional flight plan and getting a better idea of the mission that we flew to capture this. Another thing you can do in the point cloud is select an individual point, and every time you select an individual point, you're going to see all these green rays shoot up. That means that individual point was captured in all of those images in which the rays are shooting up to. And on the right-hand side, we can see all of those images load. So you can click on those, and you can see that green cross showing exactly where you clicked on in 3D space in the 2D image. So you have that 3D to 2D connection, and Nate's going to talk about that when he talks and addresses that Pix4D survey data import. But lastly, just to go over the outputs, the software, that folder that we created earlier is automatically going to generate those files that we need for survey processing, and right there we have our LAS point cloud file for everything that we just created in Mapper. So we'll go ahead. I mean, for this, for the purposes of this webinar, we're only going to talk about the point cloud and using that in Pix4D Mapper and Pix4D Survey, but Pix4D Mapper can also create a wide spread of different other data products, a point cloud, an orthomosaic, a digital surface model, a 3D textured mesh, and if you're dealing with multispectral imagery, an index map, and then if you're dealing with thermal, we can make thermal reflectance maps, which is really nice. As far as applications go, I sort of talked about it earlier. The software is used in so many widespread applications. This project we're talking about is more so on the land surveying side of things, but we have a lot of users in the mining industry, planning and design, and just a lot of different use cases coming out of the software. So just to highlight what I talked about, the overall Pix4D workflow. So we got those drone acquired images out there in Hawaii from GeoCue's great partner. They collected that data from the TrueView sensor. We imported that into Pix4D Mapper. We processed the data. We imported all of those additional files that we get from GeoCue to process that data accurately. Then we get that point cloud from the software, and then now I'm going to hand it off to Nate, and Nate's going to show you what we do in Pix4D Survey to get a little more information out of the data products we've created and get everything ready to be imported into AutoCAD. So with that, I'll throw it over to the great Nate Moore.
Awesome. Thank you, Josh. Here, let me share and we'll be on our way. So, can you guys see my screen okay, Josh?
We can.
Great. So, yeah, I think what Pix4D Survey is here for is to extract what you need, and it's very much literally a next step in workflows. We're not a photogrammetry tool, but we can take all those great photogrammetric outputs that you've made in Pix4D Mapper or in the Pix4D Cloud or Pix4D Matic for that matter, and bring it all along so that you can really simplify that extraction out to GIS and CAD. And what's really great about all the front end work that GeoCue does is it gives us not just what we need for the photogrammetry, but also the precision of that really nice, really complete coverage point cloud. So you've got the two, and I'm going to show you how you can use those, the photogrammetric and the LIDAR outputs in a complementary way to be able to really collect all the data that you need and really get everything that you need in your workflow, hopefully quickly and efficiently. That's our real goal. We're not trying to give you a million features, just the right ones. So this is kind of the old ecosystem around Mapper that you guys probably know from the last couple of years. So you can go out, you can acquire a big project, you can process a big project, and then you've got to do like a bunch of stuff. And that's where a lot of the time goes, often days and days per project before you can pull out the right stuff that you need to move it over to your CAD and GIS. So we're really trying to help you here in the middle. So this is kind of where we're at now, purely on the Pix4D side, where there's the acquisition. You can process it in Mapper or Matic, and then bring it along over to Pix4D Survey. And you'll see we've got a handful of options in there. There's not a million things you can do, but what you can do quickly, and it's pretty easy to do. So I think you'll find it's a nice way to complement what you've got at the moment. So speed, accuracy, data compatibility, so really simple formats that you're going to be able to use in other places, and take advantage of those images, because while the point clouds are beautiful, there's often that gap or something that can't be reconstructed. Like in this example here in the background, there's those wires. No matter how you're doing your data collection, it's going to be really hard to get those fine overhead wires. I mean, these are, in this example, those are the overheads on a train line that's centimeter diameter, quarter of an inch, something like that. It's pretty fine, but if you're flying high resolution imagery, you're going to be able to see it in there, and you can fill those gaps by using the images. So what we're really focusing on, I actually touched on it here, is on terrain. So that's our first thing that we're really going to let you do, is do your vectorization. Any layers that should be break lines or otherwise part of the terrain, you can tag those. Make that terrain including the break lines, which is a new thing for us at Pix4D, and then push it all down the road to the rest of your workflow. So let me quickly share survey there. So this is that same project. You've seen it a couple times, a couple different ways now. What I did here was just a drag and drop import. You can see it here. I dropped in the P4D that I got from Josh. Full disclosure, because I did know that back in TrueView, it was in GeoCue 12B. I did make a little edit manually to the text of the P4D, but the benefit of that, because we knew that it was GeoCue 12B for everything, and that's just not in the list for Pix4D Mapper. You can see now we actually have a proper horizontal and vertical coordinate system here inside Pix4D Survey. So we're trying to keep the coordinate system list update current and give you guys all the stuff that you need. So I did two things. I pulled in that P4D to define the basic Pix4D survey project, because that's the only way that you can get your point cloud plus the image relationships. And similar to Mapper, you can pick anywhere inside Pix4D survey here and get the resulting images, so you really have that link between the two on where you are. And the other thing that I did was I dropped in the GeoCue point cloud as well. So we're actually looking at the two of them here together. So I'm going to show you just one at a time so you can see them a little bit in context and see what those differences are. So thanks to having port and starboard cameras and really good IMU information, we got a really, really great mapper result. And that's what we're looking at here, where you can see it's super crisp, it's super detailed, and we have the relationship with the images over here as well. Now I'm going to go ahead and turn that off, so there's nothing there, and we can look at just the same area in the LIDAR point cloud here. Now you can see here, this is actually picked up a little bit more of what's going on in these panels here. So those are some kind of there's a material there that we did not see at all in the imagery. So that's good. So this is with the images. So in fact, without using the point cloud output from Mapper, you can still leverage your coordinate system information, use your coordinate system information or data in the same area to be able to pull it all together. So you can really fill the gaps between your different data sources if you should have any. And you'll also tend to have things like different extents for the whole project. So they're really nicely complementary, and you can start to kind of tell the whole story by using the two together. So just to give you a really quick overview of what survey is about, I came in here and I already did a bunch of vectorizing, nothing too much, nothing too crazy. But I just wanted to kind of let you see what's possible. And in fact, I don't know if you guys are having my screen go black here and there, but it seems like it's an actual hardware problem here on my side. So my apologies for that if you're getting any of those flickers that I'm seeing. Let's take a look here. So this is a part of the project where I did not do too much vectorizing, and I want to just show you that basic bit of a workflow. So you can see here, we can see pretty well in the point cloud what's going on, and I see here in the image, for example, that there's that manhole there. So if I wanted to really quickly take a look around here and start adding a couple of things like manholes, I can use our vectorizing tools to do that. And as soon as I make it sound so easy, as soon as I place that point here, it is a live demo. There we go. You can see that starts to come through and you can actually see it in the image there. Now, you can work your way through and see if you see anything else in the point cloud, and you can always, start to try and do your actual initial, any other line work that you might be doing here. So in this case, I'm gonna, since my machine isn't exactly cooperating here, I'm gonna jump back over here where I already did a little bit of vectorizing. And if we take a good close look here, you can see, I think it's my graphics card, but I can't quite tell what it is that's going. Here, what I've done is vectorize the top of the curve. And so what that is, I'm gonna make this maybe just, if I make it a little bit smaller, maybe it'll cooperate better, I hope. Again, my apologies, but I'm really stuck here. Huh. Okay, let me try it this way. That screen just died. So let me see. Let me quickly just switch back over here and we'll go on our way. So there, let me get the control panel out of the way. So this here, top of curb here, you can see is the bottom of curb, and I've tagged those as terrain layers. So what that means is that when I go ahead and do any further processing with them, they'll actually be treated as break lines. Now I can come in here and pick a single vertex if you want to see what's going on there. And I often will actually just refine everything in the 3D, but if you want to refine it in the 2D, that's possible as well. So in this case, you can actually come in here. Now, this is a difficult one because it's a little bit hard to see, but if you know that you want to move this over just a tiny bit in the images there to fit better to the bottom of the curb, there's really nothing great to be visible there, but in this case, you can still do it. And now you know that that's going to just apply right there. So let me apply that. And then we can kind of move along on our way from there. So I just want to really quickly show you this processing set of options over here. You can see in this case, I already ran it. And these, if I recall, those are the actual settings that I used. So I'm going to turn that filter back on. So now you can see we've got this kind of bluish non-terrain and the rest of the world there, the terrain is in that yellow. So you can swap over to display that in natural color, hide all your non-terrain. And now if you know that you're going to be having to come in and vectorize the roadways, really figure out everything that you need to get the true terrain and understand where your water is going to be flowing, you can really get quickly and easily do that. There's that big, beautiful building here, but frankly, it's just in the way when I'm trying to get to all the points I need out in the street and the, surrounding grass and everything. So in this case, what I did was I decided I wanted a grid of points. Think about spot elevations. 15-foot intervals. I ran that grid and I got this result here. So I just turned those on. You can see a nice set of red points there just on the terrain, and that will be what we use later on to make this tin. So I'm going to run a tin there, and let me just make sure I've got everything set here the way I want it. And yeah, looks right. I'm going to generate that guy, and then there we have it. So because it runs so quickly, it's a really nice way to see if you've got noise going on, but also to just see what your whole project looks like. So if we turn off everything else, you can see It's pretty clean. It's not quite perfect. One thing we've got here is those are some manual points I added in because it actually didn't classify too terribly well over there. So let me turn off the tin and turn that back on and let you see everything here. And you can see we've got a stockpile there. And for whatever reason, I think because it's close to the building and the crane base and everything else, it just didn't classify terribly well. Now, you do have, of course, the option to come in and reclassify bits and pieces of that. So in this case, you could come and, pick something, assign it to terrain, and then when you went ahead and ran the grid, it would include this in that bit of feedback. So I know that was the real whirlwind tour of what you can do, but it's really about doing simple vectorization quickly, making it easy to learn, easy to train, and get you the right information using the images plus, and that's the key, I think, is images plus the point cloud. So basically, my recommendation to you is if you want to work super quickly, do it straight off the point cloud. If you want to try and do, something a bit more detailed, then start to look at using the images. This is a good example of where you can really see, these are pretty small, well, no smaller than normal, I suppose, solar panels. You can see there, I just, vectorize that one. You can come in, come on. I say it like it's so easy. It's just not cooperating for me today. Anyway, normally you come in, you edit it really quickly, and you can see the relationship with the images and use that to kind of take advantage of the whole thing. I'm just going to take 1 second and tell you a little bit about what's next, and then I think we'll take your questions and call it a day after that. So the next thing we're going to do is a smart grid of points. So rather than that just equally spaced grid that you saw there, we're going to make that available in a way that will just interpret places where there's changes in the terrain. So it'll start to automatically find those break line points for you or anywhere where there's a terrain break. We're going to do more automation and thinking mostly about terrain at the beginning, but then after that, there's a lot of other nice things we can start to automate using the images and the point cloud together. And then after that, I'd be really curious to hear what would save you guys the most time. When you've got these great point clouds from all different sources together with images, what is it that you see as the value for you and what would help the most? And if you want to give this a try, go to pix4d.com/survey. And there you can find an installer for Windows and Mac, and there's some demo data sets, the whole community, all the documentation, all that good stuff. And back at the beginning of the document, you've got my email too if you want to get in touch. So with that, that's my piece. And then I think do we have time for questions, Crystal? How does it look?
Yeah, Martin, do we have any questions that we'd like to share with everybody to go over?
Sure, we do. Yeah, we've actually got a fair number of questions coming in. Maybe just a quick clarification, Nate, someone was asking, the point cloud you were using there, were you digitizing from the combined TrueView, so from the combined LIDAR and image labs, or was it one or the other?
It actually, once you've brought them both in, and in this case, these two really aligned perfectly, we don't discriminate. You can turn one on and the other off, but because everything is geo-referenced the same way, we treat them the same. So you're still able to work between either point cloud and the images.
Okay, perfect. All right, and the combined cloud as well, right?
Exactly.
Perfect. There's a question here, maybe this is for you, Lewis, just in terms of achievable accuracies. I think they're talking about the point cloud, but can you talk a little bit I know you have the specs up there, but you can talk a little bit about the accuracies you can achieve in final products from TrueView and these kind of workflows?
Yeah, sure. On the LIDAR side, and I'll say real quickly, I apologize for technical problems. I noticed Josh was having problems, and I think I was having the same problem. So I think it's just the environment we're working in today. I had just practically frozen mouse movements, made it a little bit difficult. Not sure what was going on. But on the accuracy side of things, on the TrueView 410, I like to say that's a 5.5 system. It's a 5 centimeter, better than 5 centimeter network accuracy. Some people call that absolute accuracy, and 5 centimeters of precision at 1 sigma. The 615, 620 are more in the class of 2 centimeters network accuracy, and more in the range of 1.5 centimeters of noise at 1 sigma. We flew a 620 at a big test range in California last week, and we had uncorrected, no bias correction or anything, network RMSE accuracy over 75 targets of 1.8 centimeters. So quite good.
Great, thanks. And perhaps Josh, you might want to take this one. Someone just asking about, so we've got the data set here with the construction site. If this was a completed building and there was some, there was some BIM work or some internal scans that had been done, can you kind of combine those in your Pix4D project? Maybe talk a little bit to that workflow.
Yeah. So that's a possibility as well. So this project, I mean, everything was aerial with the TrueView sensor. I mean, the RGB imagery is aerial, the LIDAR sensor is aerial, but a lot of people will actually take terrestrial photos either with a DSLR camera, a cell phone, whatever it may be. They'll capture ground-based images and then import those into Pix4D Mapper, all the same, process them, and then import them into Survey and combine your drone-based point clouds with your ground-based point clouds. And we actually just came out with a super cool software for this called Pix4D Catch. It's compatible with the iPhone and the iPads that are just released by Apple that have the integrated LiDAR sensors, which is really nice. And it's basically a cool app that'll go through and automatically take perfect terrestrial images for Pix4D processing. So check that out, Pix4D Catch.
Excellent, great, thanks. Well, I think we're probably coming up to, actually we've gone a little over our time, so I'll toss it back to Crystal. We do have a couple of more questions that were submitted, and we'll follow up with you. If you submitted a question, we'll follow up with you with email and get you answers to those that we haven't had time to address today. So with that, I'll toss it back to Crystal.
All right, thank you, Martin. All right, so I'm going to go ahead and launch 3 poll questions to close us out. So our first poll question is, what do you see as the biggest advantage of TrueView plus Pix4D survey for your company? And while we get our answers coming in, I just wanted to thank Nathan and Josh again for joining us and everyone who attended our webinar today.
Yeah, thanks for having us, Crystal. I mean, this was a really cool webinar. I mean, you guys make an absolutely awesome sensor, so it was only right for us to do a cool webinar with you guys.
Great, thank you for that.
Yeah, and I really I appreciate it. I remember back in like 2005, I worked at a nonprofit and we were trying to set up our own like 5-beam laser tied to photogrammetry, and it was really hard and it wasn't very good. And your stuff is just amazing.
Thank you, thank you. We're going to go ahead and launch that second question, which is, what is your interest in GeoCue's TrueView systems? And if for any reason you don't think the TrueView systems will work with you, please feel free to email us at info@geocue.com. We'd love to have a discussion. Leave this open for a few more seconds before we launch that last one. Okay. All right, and our last question was your interest in Pix4D's product offerings. And that will conclude our last poll question for today's webinar. Thank you again for joining us. We hope you continue to stay safe and healthy. This webinar has been recorded and will be distributed to everyone registered. So thank you again, and we hope to hear from you soon.